In this presentation, we're going to look at a tutorial question that deals with probability and expected values. The question is, a player tosses two fair coins. He wins $2 if the experiment yields two heads, $1 if there is only one head, and he loses $3 if no heads occurs. In other words, two tails. Find the expected value of this game, denoted E of x, and is the game fair? Now, the game is considered fair if the expected value of the winnings, which we're going to denote x, is 0. It is favorable to the player if the expected value of the winnings is greater than 0, and conversely unfavorable if the expected value of the winnings is less than 0. So first off, we have to determine the probability of 0 heads, 1 head, and 2 heads. And what we're going to do is construct a probability tree. So bear with me. So on this tree there are 4 distinct paths. The first path will be heads in the first row, heads in the second row. Another path will be heads in the first row, tails in the second row, and so on. So we're going to write out the sample space here that will correspond to this tree. Heads heads, heads tails, tails heads, and tails tails. Now we're also interested in the number of heads in each case. So in this case, I'm going to change the pen color there. We have 2 heads, 1 head, 1 head, and 0 heads. Now, we're specifically interested in the probability of each of these outcomes. So the probability of 2 heads, throwing 2 heads, is as follows. Well, first off, we know it's a fair coin. So the probability of head is 50%, probability of tails is 50%. And we have 2 independent events. So we're going to multiply 0.5 by 0.5. And that gives us 0.25. So the probability of head is 0.25. So the probability of 2 heads is 0.25. This would be the same for all the other cases. The probability of heads tails is 0.25. The probability of tails head 0.25, and 2 tails 0.25. So what we're going to do now is set up a little frequency table, a probability distribution table, and that is going to be the basis for answering this question. So first off, we have the number of heads, 0, 1, and 2, and also we are interested in the winnings that correspond with the number of heads. So if there are no heads, we lose $3. If there is 1 head, we win $1, and if there are 2 heads, that we win $2. We're also mark down the probability of each event, 0.25 for 0 heads, 0.50 for 1 head. Now that's a combination of the 2 middle heads and tails and heads. It's the 2 values together. And lastly, 2 heads is the probability is 0.25. So now we're going to compute the expected value using this table here. So what we have to do is compute the formula, or write down the formula we're going to use, and that is the expected value of x is the sum of each outcome times the probability of that outcome. So what we would get is minus 3 times 0.25 plus 1 times 0.25, or 0.50 actually, and plus 2 times 0.25. So that is equal to minus 0.75 plus 0.50 plus 0.50, and that is equal to 0.25. So the expected value of the game is equal to 0.25. So that's the expected value. Now we're also asked, is the game fair, favorable, or unfavorable? Well, it's not fair. The expected value is not 0. The game is actually favorable because the expected value is greater than 0. So just make a note of that. It's not fair. It's actually favorable.